Okay, here we go with example 2 for surfaces of revolution. We want to revolve the function y equals square root 1 plus e to the x on the interval 0, 1 about the x-axis. And so let's just get right into it. So we want to just plug in the requisite pieces into the formula. First, I want to find the derivative of this function. And I'm going to do this with the chain rule, because I've got an inside function, 1 plus e to the x, and then the outside is the square root. So I'm going to do the outside. The derivative of a square root is half x to the minus a half, but I'm going to keep it there. And then I have to multiply by the derivative of the inside. The derivative of 1 plus e to the x is just e to the x. And so I'm just going to simplify. I'll leave the e to the x on top. I'll put the 2 on the bottom. And then this minus a half power I'll put as a square root. It's in the denominator because it's a negative exponent. Okay, so now I'm going to square it. And I get e to the x squared over, remember I'm squaring both of them, 4 times 1 plus e to the x. Okay, so now what's 1 plus this squared? Well, that's 1, not plus, that's equals 1 plus e to the 2x over 4 times 1 plus e to the x. Now I need to simplify, so I'm going to combine the fraction to see what happens. 4, 1 plus e to the x. And the 1 turns into a 4, 1 plus e to the x, and then the e to the 2x stays. And now I'll just distribute this. I get e to the 2x, 4 e to the x plus 4, over 4 times 1 plus e to the x. So that's 1 plus y prime squared. Now I'll plug the rest of it, that's this right here. I'm going to plug the rest of it in the formula. So the surface area is it's 2 pi integral 0 to 1, because that's my interval, 2 pi f of x. 2 pi f of x, that's the square root of 1 plus e to the x, times square root of this. Square root of this. Square root e to the 2x plus 4e to the x plus 4 over 4 times 1 plus e to the x. And this looks really gross right now, but there's actually a lot of simplification that happens. Check this out. The first thing I notice is that I can write this as a perfect square. I can write this as e to the x plus 2 all squared. You can FOIL that out and see if it works. I'm remembering that e to the x squared is the same as e to the 2x. That's right here. So once I take the square root of that, that goes away. 2 pi square root of 1 plus e to the x. Now I got to take the square root of the numerator and denominator. When I take the square root of the numerator, this cancels. I get e to the x plus 2. And then I got to take the square root of the denominator. That gives me a square root of 4, which is 2. Easy to forget that. And then square root of this. And look at that. It's all cancels. These two cancel at least. And this, oh, I wrote the 2 pi twice here. Whoops. And now this 2 and 2 cancel. What am I left with? I'm left with pi integral 0 to 1 of e to the x plus 2. Now I can just integrate. Antiderivative is e to the x plus 2x, 0 to 1. And I get e plus 2 minus e to the 0 is 1, and 2 times 0 is 0. And I get pi times e plus 2 minus 1 is 1. And that's it. Hope that helped.